Welcome to Tropical Cyclone Update. Currently we have a tropical storm in the Western Pacific, Tropical Storm Hinnamnor, and I found the name so difficult to pronounce that I'm just gonna say 12W. 12W is currently situated just south of Japan. We can see it here on the water vapor imagery, where we have here Japan and the tropical storm currently moving pretty much westward. And this storm is likely to intensify quite a lot in the next few days, and it could be a pretty significant threat to the southern Japanese islands. So let's look at the structure of the storm. We have a pretty decent fanning out of the outflow, low-level easterly flow pushing the storm toward the west. We have pretty intense looking vertical hot towers curling around in the storm, indicating the intensification of it. This is a pretty nice looking deep convective and compact CDO, central dense overcast. I wouldn't be surprised if tomorrow we could see, with this currently still from the JTWC tropical storm, we could see a typhoon or even a major typhoon if this does undergo a rapid intensification, as it looks currently has some of this look of a rapid intensification event, with those overshooting tops rotating around in the center, rotating around and releasing a lot of heat into the atmosphere. We had just about 2 hours ago microwave pass, where we have the center here and curling banding trying to close off an eye wall on the eastern side. And when we go back on the IR loop, we see that the time frame we had this microwave pass was roughly around here, and we can see since then, since the frame, there was still a lot more improvement. So it could be that we now have a more or less closed eye wall structure with the storm. Looking at water vapor imagery, we have this storm being here, and then we have this ridge pushing the storm toward the west southwest. Here we have, it's a large scale trough which came from an anticyclonic wave break downstream, pushing down with a lot of flow, a lot of these northeasterly flow, which causes the storm to not be picked up by this upper trough near Japan, which is currently digging down. So there have been some solutions which had the storm quickly recurving or just moving into Japan and then recurving, but as this flow, this northeasterly flow, is mainly rooted in the upper levels of the atmosphere, the stronger ensembles had the storm dipping further southwest than the weaker members. Weaker members just went into Japan, and as the storm is probably a lot stronger than the main ensembles have been showing, this southwesterly trajectory is a lot more likely than just recurving into Japan. And we can see this on the GEFS model. We have this ridge here which is pushing the storm, and the trough is not able to pick the storm up. And here this big large scale trough from the anticyclonic wave break we had before. So we have this belt of upper level easterly flow pushing the storm towards the west southwest, and then it arrives roughly at the southern Japanese islands. This is about 4 days out, and then we have the steering flows a little bit of competing. We have this upper level ridge over China, and then this trough which impedes still the northeasterly flow in the storm, while the ridge does northwesterly flow. So the storm really doesn't know where to go, and it slows down in trajectory, slows down in forward speed. So it doesn't really know where to go, and then eventually gets picked up by this trough which moves in. But we could easily, as the HWRF has been showing, for example, it could easily stall right over the Japanese islands for a good 1 to 2 days, and as a significant typhoon as well. So there's a significant threat for the southern Japanese islands here, that this typhoon could be lingering for some time at great intensity, as well as this environment is really favorable. We have good equatorial outflow, and the polar outflow channel is also there. So there's a lot of divergence around the storm, very low wind shear, and this is a favorable environment for intensification. As we're seeing right now, the storm is already intensifying more than expected, and it could be a pretty significant threat. When we go to the 500 millibar vorticity plot, we can see this as well. With the competing steering flows, we have this here in the mid-levels, the south easterly flow from this 500 millibar ridge, and from the ridge over China we have this northwesterly flow, and they're about of equal strength. So this storm doesn't move because it has, on both sides of it, it has competing steering flows. So yeah, that's what I got on the tropical storm 12W currently. And I want to talk just a minute about the Atlantic. So on the beginning of the Atlantic season, we all thought it's going to be an active season. Sorry for the mic. We all thought it's going to be an active season. We all thought we're going to have like a crazy number of A's, like 180 was something that was frequently forecasted by a lot of people. And so far the Atlantic has been really lacking activity, and it has been incredibly inactive actually. We had about 2.8 ACE, accumulated cyclone energy, so far, which is in the top 10 bottom seasons until this date. And so far August hasn't produced a single tropical storm or tropical cyclone at that. So currently the Atlantic is running very inactive, and I think there are two plots that can easily show why. First of all, this here is the 200 millibar geopotential height. So it practically shows where the troughs and ridges are in the upper levels, and here we can clearly see this big, very dominant ridge over the northwestern Atlantic, and just below this we can see here troughing anomalies, negative height anomalies, which essentially caused which are essentially caused by a wave break happening here. So this pattern, we have ridge, and then the Rossby waves coming in here, and then they break around downstream from the ridge, and then they drift down here, this positive PV, and it causes a trough in the upper levels, which imparts wind shear. And when you look at a zonal anomaly chart, it basically follows this gradient, and we had anomalous wind shear throughout this region of the basin. Additionally to the anomalous wind shear over most of the Atlantic, roughly in this area, we also have particularly dry mid-level air, essentially in the entire middle part of the basin. We can see that Africa is relatively moist. There is positive anomalies of relative humidity in 500 millibars in the mid-levels, but then it completely dies off, and the central part of the MDR is good bit drier than it usually is. And I think this is mainly caused by this anomalous ridging here over the northern Atlantic, advecting a lot of cold air from the northeastern Atlantic and out of Africa into the main development region. And also some of the waves we didn't really have those small, compact, robust wave, but mainly the waves we had were like big monsoon gyres that were pretty easy to get entrained by dry air because they were just so huge and broad and couldn't take advantage of the low shear environment they might have encountered, because in this region we didn't really have anomalous shear, we just had a really dry mid-levels. And there's also a cooler blob of SSTs sitting right around here, and where you have advection of air from the northeastern Atlantic running right through this blob of cooler waters. It can't warm up enough, it can't moisten as much as it usually does, and so you get a dry spot, anomalous dry spot in the main